Okay, let's pick up our conversation on business processes in chapter two. Okay, when we one of the points we talked about in chapter one, we kind of use this as our starting point, is what we call Porter's value chain, which is a model that Michael Porter developed um, that separates an organization's activities into two broad categories. One is what we call the primary activities, which would include inbound logistics operations, outbound logistics, marketing and sales. These activities right here really are categorized by the creation of the product, the shipping of the product, engagement with the customer, and each step along the way is thought of as adding value to the product as you're going through. So the value chain is really these primary activities, as Porter um, as Porter describes it. It's really kind of a set of business activities, business processes that are specifically designed to align with the product creation. And then everything beyond that is falls into what he calls support activities. So these are shared activities that are important for operations and for business execution, but they're not necessarily on the direct line. So the idea of where the term value chain comes from is these ideas as you move through the primary activities, each step along the way is a value add. Okay, but if you look at this also, the other way you can look at this as Porter's value chain model is each one of these blocks is really a set of processes, business processes, which are specifically designed to, as we talked about before, business processes, a series of tasks that have a expected outcome. And the idea is that each one of these boxes is really a set of business processes. A set of business processes around inbound logistics, a set of business processes around operations, a set of business processes around logistics, and so on. And each one of these processes, are integrated. This idea of all of these activities become an integrated coordination of all of the activities. So the idea of creating a competitive advantage um, is the idea of you can be able to, if you can organize your business processes in such a fashion so you can use it to either differentiate or reduce cost, that would be a clear advantage. So the supporters model, as we look at the model here, is it's a restructuring of kind of your traditional organizations where you kind of your top down, because it actually goes not so much top down, but more of a left to right as we go through as we execute all the processes in the value chain, and then also the ability to coordinate and consolidate activities, for shared resources. Whereas in traditional models, a lot of these activities would be duplicated all throughout the different pieces of the organization. In the value chain model, the support activities become a shared resource. Um, the idea is really if this can be done, if this can be achieved, an organization can gain significant advantage. The challenge is though this restructuring of an organization and a realignment around business processes, end-to-end business processes, is was has been for a lot of organizations very challenging to achieve. So one of the key aspects when we talk around business, the key attributes of business is really decision making. Basically, organizations, managers are in the business of making decisions, and making decisions is difficult, primarily because the outcomes of a decision may or may not yield the desired result. So ideally, what in a perfect world, what you would like to have would be able to make informed decision making. So the idea of understanding, what as much of the circumstances, being able to weigh possible outcomes, probabilities of those outcomes, all of that types of information ad- becomes very advantageous to have that in order to make good decisions. Um, the idea of an organization, the idea of what you want to do, the outcomes of these decisions around efficiency and effectiveness. The idea of being able to, to weigh all of these and be able to monitor it through things like metrics and key performance indicators are very important. So there's different layers. If you look at kind of a decision-making model, this idea of information, you know, different tiers of information. So if we look at our bottom here, our kind of our operational level, this is this is really the activity where you look at where a lot of the work gets done in an organization. All right? So this idea of gathering data and turning data into information, focused really on your operations. This is what we do. This is how we make stuff. This is how this is what our core processes are. This is how we execute. That's all part and parcel of this operational level. The next level up, though, is what we call managerial types of decisions or managerial types of activities. And those types of decisions are really around answering questions or trying to gain additional insights. At the operational level, we're focused on things like reporting. How much did we do? How many things went right? How many things went wrong? Whereas at the managerial level, we're focused more on answering questions. So we'll ask a question like, how did we, if we measure this quarter's performance over last quarter's performance or 5 years running performance, how do things match up? Are directions up? Are they down? Are there correlations between, like new customers and new products, or are there products that are not, that are sitting on the shelf and are non-succeeding? So all of these we call what we call managerial. And it's really, if you think of it in terms of answering a question, asking a question, and then deriving an answer. That's really what we call in terms of this business intelligence. And this third level, this third tier, top tier, is we call it here knowledge, but it's kind of the strategic view. The idea of what are from the top level of the organization, how are things performing? How are are decisions are being made at operational levels? What is the impact on that in terms of overall direction of the organization, and how is it manage up against the vision about where the organization should be going? So this is really at the senior level, and focuses on things like, for example, is the organization achieving what it is striving for as part of its strategic plan and direction? So that if you look at kind of the characteristics, the attributes of these different tiers from an information level, this has actually been a pretty traditional part of data processing. This idea of reports, generating routine, structured information, collection, aggregation of transactional information, and then generation of a report within some time frame, within a day, a week, a month. All right. This managerial level, this tier here, this business intelligence tier, is actually comparative to the operational stuff, a little bit newer. So it's probably within the past, say, 20 years that we've seen a greater emphasis around this. And a lot of it was driven by the fact that the operational systems, newer operational systems, could generate large amounts of information, but they weren't really necessarily focused on answering specific questions. So what we saw was, and what we'll see as we talk about this a little bit in the future, this tier here was actually created, with the specific technologies and specific tools to be able to analyze data, to be able to do, take semi-structured and adaptive types of information, be able to ask questions and get answers, provide insights. And then this third tier, the strategic layer, is the characteristics. This is actually a place that is still in development right now. So when we talk around things like machine learning and different types of analytics, more in-depth analytics around machine learning um, approaches. This is at. Whereas the operational actually managerial are pretty mature. Strategic is an area where there's still a lot of new developments and a lot of new activity going on around that. This idea of these different types of data, different types of decisions, translate to different types of applications. All right, so if we look at we kind of measure, we kind of chart this out, kind of measuring structured, semi-structured, unstructured against operational, managerial, and strategic levels. What we see is a matching of applications, kind of a set of applications that kind of are specifically designed. So if we look at this structured operational um, characteristics, what the types of applications that we work with in these areas are what we call transaction processing systems, or we call OLTP, which stands for online transaction processing. And what these systems do is basically they do the day-to-day activities of an organization. So they'll take sales orders, or they'll post, or they'll ship products, or they'll process accounts payable or accounts receivable. All of the day-to-day activities, which are really described within the business processes. That's really what these OLTP systems do, and we'll discuss a little bit more in the future. But things like ERP systems, CRM systems, supply chain management systems, all fall into this category here. These OLTP systems. So this next tier up here, these decision support systems, are designed to be able to do business analysis, be able to do more sophisticated reporting, answering questions that managers have to support decision making. Right? So there's a specific types of applications that are different than OLTP. All right, so this is what we will call OLAP, online analytical processing, with the differentiator from OLTP. Right, so these are what we call decision support systems. And then finally, our executive information systems, which are really specifically designed for really kind of provide an abstracted view of how the organization's running. Is it, if we look across the board, if we establish certain rules for, what the expectations are for operations, or, is it red, is it yellow, is it green? So there's a whole series of specific applications that are designed. Whereas, this is, as we look at the details, this is extraordinarily detailed, a little less detailed, and actually not detailed at all. All right, so this is kind of the relationship between these two, and these three different types of applications. One of the things we will be talking about with dashboards, which is a form of executive information systems. We will actually be developing a dashboard later on in the course. All right, so talk a little bit about business processes. And as we said, if we look at Porter's model, basically Porter's model, each one of these blocks is a set of business processes that are focused on that particular area. So like inbound logistics would be, I guess, the things like inventorying and tracking and allocation of materials to processes and things of that nature. And receiving of materials inbound, and assignment of materials to storage locations, all those types of things, which translate to different processes. And there's a process for every one of these things. So what we see right here, this inbound logistics is really a set of processes which are distinct from the operations processes, which are distinct from the outbound logistics processes. However, there's an integration point for each one of these. So one of the things that differentiates kind of this model here is that these are actually, it's integrated within, processes can be integrated within a particular block here, but it can also span. So the idea of, Activities within inbound logistics, have integration points with operations, which have integration points with outbound logistics. So the idea is that what you will end up doing is, this will, the term that gets used a lot is end-to-end execution. So the idea is that, starting from one point, there's a seamless, is an execution, a starting point, a process or an execution, and then an output, which then is transferred over into this next one, which has a set of processes around it, and so on and so forth as you go down the line. So ultimately, all of these, the idea is all of these activities are integrated together, whereas in your traditional model, a lot of these activities are done in different vertical silos. So the idea is, your inbound logistics were not necessarily bound to or integrated with your operational stuff. So, things, there was a connection point, but it wasn't really integrated in the sense of things having an end-to-end connection. All right. So, some of the characteristics we talk about with these business processes are, number one, they are cross-functional in nature. All right. So the idea is that, they cut across the value chain. So different departments are all linked together or coordinating activities across different. Uh, if you kind of look at each one of these as being each one of these is being bounded, crossing the boundaries, and being able to execute and handle things on an end-to-end basis is very important. The idea of also these types of things, these types of activities, um, can be automated using transaction processing systems. So if you go back and look at kind of what we were doing mid '90s, a lot of that what we were doing was kind of a combination of a couple things. Number one, we were rethinking the way the business operated and the way business processes were approached. And in addition, we were implementing systems that supported that. So this automation and implementation, and we'll talk about that a little bit when we talk about ERP systems and the implementation, some of the history of ERP systems, kind of where this stuff went. So the advantages, it give us the idea of these systems will give us a proper workflow and efficiency and effectiveness. In dealing with efficiency and effectiveness, the ability, these systems, especially as things are all tied together and data is captured on an end-to-end basis, they can be measured for efficiency and effectiveness. Whereas, like in your traditional system, in your traditional environments, where you really, where each operation kind of operated on operated vertically as opposed to horizontally, you really could not. It was difficult to identify, where were your problem areas, your points of your bottlenecks in the systems, and one of the key areas that was involved as we were developing a lot of these systems was kind of debottlenecking, identify where are the pinch points, and then streamlining them, and then eliminating things like redundancies and being things, developing efficiency and effectiveness, and then measuring it, and then going back and evaluating those measurements, and then redesigning as necessary. And then finally, this idea of reengineering, business process reengineering, the idea of focusing on value with the idea of the purpose of these processes is really to provide value to the customer. So each one of these areas, and particularly in the end-to-end process execution, the focus is really on value, customer value. And here's just a diagram of, we would call this becomes, a description of this one is what we call a order to cash process. So the idea of it, in order to cash, a good example of order to cash would be things like, if you think of Amazon, probably the best example. Customer logs onto the website, goes to purchase something, applies say a credit card or whatever payment form, information of their their shipping, other information is saved. The information is then passed over to the warehouse. The warehouse will then pick what the customer wants, run through customer quality assurance to verify that it is what it should be, and then it is shipped out to the customer. All right. So this goes from order as we pass through to at the end, as when we do a post goods issue on the shipment, then to cash. And then there's also within this process, there's also potentially a customer service engagement. So say, for example, wrong product, wrong color, returns, modifications, damaged goods, things of that nature, operating through customer service back through the cycle again. So this is the characteristics are that, it's different groups, different areas working together to execute on the end-to-end basis. Some of the impacts of business process reengineering, restructuring, kind of reorganizing in such a way, and debottlenecking these things has some pretty significant impacts. An example we use when we talk around claims resolution, for a auto insurance, a claim, a lot of manual systems, very paper-oriented systems traditionally, it can take anywhere 3 to 8 weeks. You have an accident, you bring it in, you schedule an appointment, you bring it in, the claims adjuster will evaluate, pass that information off. Information will be would be passed over, identifying a repair shop. So the resolution, the end-to-end resolution time, could be 3 to 8 weeks, depending. And if we look at kind of an approach like with Progressive Insurance would be an example of of what they've done. They've automated, re-engineered and automated their claims resolution process using technology. So the idea of being able to, instead of having to go into a shop, basically being able to use like your cell phone to be able to capture pictures of damage, electronically send it into the shop, be able to have automatically detect that workflow, be able to create a workflow, processing the information, passing along. Resolution of that can go down from the 3 to 8 weeks to 30 minutes to 3 hours. All right. And different processes can be streamlined in different ways. So everything is the application of technology to this stuff is very important. But each process, the outcome of each process, maybe not every process is quite as dramatic as this. But each one or pieces of processes, can be optimized and streamlined and improved through like the integration, the restructuring of the process and the application of technology as a joint effort. So we talked just a bit about OLAP. All right, so some of the things we talk around, so OLTP systems. OLAP systems are decision-making or decision support types of systems. Some of the types of analysis, what-if analysis. Here's our circumstances. What if we do this? What if we do that? What's our probability? Applying probabilities against information we've gathered, from past activities and trying to predict future results. Sensitivity analysis, goal-seeking, optimization. These are all planning types of activities. These are all the types of things we will see in an OLAP type of environment. And then for executive information systems, what we see is things like ad hoc reportings and dashboards, artificial intelligence, or as we call it now, the modern term is machine learning. Just a quick kind of give you a view of digital dashboards, and we'll actually be doing some work using something similar to this. This is a demonstration of a product from a company called Click, and they're right close to Villanova. I believe they were headquartered in Radnor. And what they do is they specialize in developing visualization types of products. So the idea of being able to take large amounts of data, transform it into information, and then manipulate that information in such a fashion to make it to be able to tell a story in effect. So if you look at, for example, this display right here, you can take a look, through a couple of different things. Obviously, with um, different types of graphics and different uses of different types of graphics, as well as colors and different styles. You can actually tell a story. So by looking at this, somebody can look at the screen without necessarily understanding kind of the nature of the business, or kind of what, without understanding the details, the individual processes that are going on. At a glance, you can get a sense of what's happening, and then some of the capabilities these things have will be things like consolidation. So the ability to take data and aggregate data and be able to make large amounts instead of individual details, be able to roll that stuff up into creating summarized numbers. And then the complement to that is drill down. So the idea is, what you'll see a lot of times with business analytics, you'll have situations where you'll take a whole set of data, perform consolidation against it, provide what we call drill down. So the idea is, behind the scenes, if you look at the summarized numbers, and then provide the ability to come back in and look at the data that makes up that consolidated number. Some of the other stuff we have here, slice and dice, be able to look at data from different perspectives, as well as pivoting, be able to take comparisons of different displays of data. So things we could look at would be different locales or different time fences or time dimensions of data, be able to look at things and be able to look at it from different perspectives. So this is something we'll see. We'll be doing some work with dashboards to get a little bit more familiarity, but this is just kind of an introduction of it. And then one of the big areas that's have been in progress right now is this idea of artificial intelligence. So it's we define artificial intelligence. It's a simulation of thinking, human thinking, in order to facilitate unstructured decision making, using data and information. All right. So it's actually been around for some period of time, but what's happening, I think the characteristics we see now is the ability, the thing that makes artificial intelligence and machine learning more possible now is, number one, is the ability to capture and process larger and larger amounts of data, which really kind of fuels this machine learning process. And in addition, the ongoing growth of computer capacity through Moore's law. So we've talked about Moore's law being kind of the rule that says, every 18 months capacity doubles, compute capacity doubles. So those, combining of those together have really provided the capability of being able to have something that is machine learning, and this is really kind of a forefront. This is kind of a leading edge technology. A couple different examples of them. One we call like an expert system, which is really a tool that will basically pull together a collection of information, rules, learnings, and provide a basis for being able to make intelligent decisions predicated on particular scenarios. So if you think about one of the big areas you see around this, like with healthcare, being able to analyze customer or a patient's symptoms, and then create a reasonable analysis of what those symptoms are, and then what the potential types of treatments would be available for them, or not just simply for medical, but for basically any area. Neural networks, which is actually has really been around. It's actually a mathematical modeling tool that's been around a while, but an application of that is the ability to, identify, track credit card activities, and try to discern ones that may be related to credit card fraud. What are the, what are nonlinear activities that kind of stand out that could be potentially questioned in terms of a customer's activity, customer's credit card usage. Another one would be what we call intelligent agents. This is an area of a lot of research right now, the creation of um, highly capable um, tools, that can be can be used to kind of complement or supplement a human's activities, decision making activities. And then finally, this area of artificial intelligence, excuse me, is augmented reality, sort of our, or we call virtual reality. So, like an example, probably an example that came out, I think, over the past week was, the Chinese government uh, are supplying their police officers with glasses that can basically do facial recognition scans. So the idea of facial recognition is you take a picture of someone, you capture the digital dimensions of their face, and then you can be matched. So the idea of you can put glasses, you put these glasses on as you're walking down the street, you can identify people who are potential criminals, as it were. Once again, that's one example, but there's other ones. There's other things like that. Uh, the thing will be interesting is the application. I mean, with augmented reality is the potential for both for good and for maybe not quite so good uh, outcomes. So if we look at the example we have here, we talk around what type of systems we would use. Um, for daily transactions, analyze daily transactions. Usually, we'd use a transaction processing system. Staffing requirements across each plant um, could either be a transaction processing or decision support system. Um, Customers at risk of default on their bills would probably be more of a decision support, some sort of analysis. Analyze your competition, including prices, discounts, goods, and services. Clearly, decision support. Um, to analyze critical success factors and performance indicators for status on operations would probably be some combination. Could either be a decision support or executive information system. The lines between these blur in a lot of ways. There's a lot of transaction processing systems have added a lot of capability of going from simple reporting and provided something closer to decision support systems. But that does not necessarily mean that has not necessarily replaced decision support systems, and the same with between um, DSS and executive information systems. So either, a lot of the cases, depending upon the particular functionality of a package, will give you, either one maybe of a particular solution to be evaluated. Um, Critical success factors and key performance indicators on status could be, a executive information system, but also decision support. And finally, a graphical display of the patterns and complex relationships for large amounts of data. Um, Probably be like an executive information system, because that's where you would take all of this information that would be running on an operational basis, and then feeding it in, and then kind of creating like a display. For example, like a display we saw previous with about the a map of the United States with specific codings in there for different degrees of either activities or measurements or KPIs that you would want to be able to present. And that is it for chapter 2.